In the vast expanse of space, an impending threat lurks, one that has the potential to unleash a solar superstorm capable of wreaking havoc on our technological infrastructure. This celestial tempest, with the power to disrupt communication networks and cripple the internet for weeks or even months, serves as a stark reminder of our vulnerabilities woven into the fabric of our hyper-connected world. Join us as we delve into the cosmic forces that could unleash a solar catastrophe, challenging the very foundations of our digital age. While we may find wonder in the beauty of the northern lights, the same energy from solar storms has the potential to give rise to what one researcher ominously described as an internet apocalypse. Professor Peter Becker from George Mason University notes that the internet has flourished during a period of solar quiescence, but it now faces a more active solar phase. This convergence marks the first time in human history that heightened solar activity aligns with our profound reliance on the internet and its pivotal role on the global economy. Becker spearheads a project in collaboration with the School of the Naval Research Laboratory, aiming to develop an early warning system for such solar disruptions. And then you have this subtle situation where you might actually generate current from the ground, Becker explained. So people assume, oh, my computer is probably grounded, it's safe. However, in an incident like this, if inductive currents are directed towards the Earth's surface, it can have the opposite effect, potentially causing damage to items believed to be secure. The power grid, satellites, underground fiber optic cables with copper sheathing, navigation and GPS systems, radio transmitters, and communication equipment are all at risk. It has happened before. The Carrington event of 1859 remains the most powerful recorded solar storm. In the late summer of 1859, what initially appears to be an ordinary day takes a surreal turn. Telegraph lines, seemingly of their own accord, begin sparking and malfunctioning, leading to fires in certain telegraph offices. Communication across the globe experiences a significant outage for several hours. As night descends, the skies transform with a dazzling exhibition of the northern lights, causing vibrant hues across nearly the entire planet. Reports of this brilliant display extend as far as Tahiti, Cuba, Jamaica, Colombia, and Hawaii. Accounts from that era describe the aurora as exceptionally bright, with reports from New England stating that people were able to read the newspaper in the middle of the night. In Colorado, the brightness was so intense that miners believed the sun was rising, signaling the start of their shifts. What transpired was a solar storm of unprecedented magnitude. The storm, dubbed the Carrington event in honor of British astronomer Richard Carrington, who observed and documented the phenomenon, struck swiftly on September 1st. Carrington, while tracking the sun from his private observatory, detected an unusual large grouping of sunspots. Suddenly, these sunspots became engulfed in a dazzling, blinding light. What Carrington witnessed was a white light solar flare, a magnetic explosion on the sun, elucidates David Hathaway, the lead of the solar physics team at NASA's Marshall Space Flight Center in Huntsville, Alabama. In a matter of hours, a coronal mass ejection catapulted through space, colliding with Earth's magnetic field and triggering an intense geomagnetic storm. This impact caused substantial shaking and quivering of the magnetic field, inducing massive electrical currents that surged through telegraph lines as per NASA. Although the Carrington event remains the most significant solar storm in recorded history, numerous other solar flares have also caused disruption. On August 4th, 1972, a solar flare disrupted long-distance telephone communications across Illinois, according to NASA. Then, on March 13, 1989, the entire province of Quebec experienced a power outage due to an exceptionally strong solar flare disrupting power transmissions from the main generating station. This left 6 million people without power for 9 hours, and power surges from the event even melted power transformers in New Jersey. Even in more contemporary times, solar flares can create issues. In December 2005, X-rays emitted during a solar storm disrupted satellite and GPS communications for approximately 10 minutes. While it may seem like a brief period, Louis J. Lanzarote, retired distinguished member of technical staff at Bell Laboratories and editor of the journal Space Weather, remarked, "I would not have wanted to be on a commercial airplane being guided in for a landing by GPS or on a ship being docked by GPS during that 10 minutes. Northern Lights activity to increase. The current solar cycle is surpassing the activity predictions made by the NOAA and NASA Solar Cycle 25 prediction panel. With an increased number of sunspots, there are more chances for individuals to experience the northern lights at latitudes farther south compared to periods of lower activity within the 11-year solar cycle. Residents in the northern United States should keep an eye out for upcoming aurora light forecasts in the years ahead, as the peak of solar activity is anticipated in 2025 during Solar Cycle 25. Just recently, the heightened solar activity resulted in mesmerizing displays of light across the northern tier. Observers in Michigan, Montana, and Minnesota reported sightings of the northern lights, casting vibrant hues of green, red, and purple across the night sky. The northern lights, typically confined to polar regions, are venturing further south due to escalating space weather conditions. Preceding the recent sightings of aurora lights in the United States, the Space Weather Prediction Center of NOAA in Boulder, Colorado, issued a geomagnetic storm watch. This alert was prompted by the detection of a coronal mass injection from the Sun, featuring a component directed towards Earth. The Space Weather Prediction Center. The SWPC has been actively monitoring solar activity as the Sun approaches the peak of its 11-year cycle. Currently, the Sun is progressing towards the zenith of activity in Solar Cycle 25, which commenced in 2019. Just this week, the SWPC issued another G2 moderate geomagnetic storm watch for Monday in anticipation of the arrival of a coronal mass ejection. This aligns with expectations as we approach the solar maximum, explained space scientist Robert Steenberg from NOAA's Space Weather Forecast Office to Fox Weather. We are heading towards the peak in our 11-year solar cycle, and this level of activity is well within the norm for such occurrences. Although the heightened space weather may not be a concern for most individuals, the current solar cycle is surpassing the anticipated average activity projected by the Solar Cycle 25 prediction panel. In 2020, the panel, jointly led by NOAA and NASA, predicted the peak of solar activity to occur in July 2025 with an expected count of 115 sunspots. As Solar Cycle 25 progresses, activity is exceeding the initial forecast. August recorded 114 sunspots, surpassing the estimated range of 59 to 109, as indicated by the solar cycle progression data from the Space Weather Prediction Center. The uptick in sunspots and coronal mass ejections provides increased chances for individuals to observe the northern lights at latitudes farther south compared to periods of lower activity in the solar cycle. Steenberg advised the public to anticipate more reports on solar activity and the northern lights as we approach the solar maximum in the coming 2 years. It will occur with greater frequency. Every now and then, among those coronal mass ejections, there will be larger ones capable of extending the aurora further south, Steenberg explained. The crucial point is not to be alarmed. There is a phenomenon the Sun has been exhibiting for a considerable period, presenting us with an opportunity to witness some truly fascinating occurrences. What can a solar superstorm do to Earth? There's been a notable uptick in solar flares, Becker explained. Flares occur when the Sun brightens and we observe the radiation. Think of it as the muzzle flash. The subsequent coronal mass ejection is akin to the cannon shot. While CMEs can disperse randomly in space, we can predict when they are Earthbound. This affords us approximately 18 to 24 hours of advance notice before these particles reach Earth and begin affecting our magnetic field. CMEs propel large clusters of plasma or intensely heated matter through space. A fraction of these encounters Earth, causing distortions in our planet's magnetic field. The ordinarily protective third prong on an electrical plug, designed to channel excess electrical charges to a safe location, transforms into a massive electrical circuit. Bird migration patterns. Researchers have discovered that solar storms, which disrupt the Earth's magnetic field, can cause birds to deviate from their intended courses, particularly during cloudy nights in the fall, when the absence of visible stars hamper their navigation. Navigational changes during migration go beyond Earth's atmospheric conditions. A recent study reveals that the sun's weather also disrupts birds' sense of direction. Migratory birds heavily rely on weather conditions during their migration, emphasized Eric Gulson Castillo, an ornithologist and the author of the study. Unfavorable weather is a deterrent for birds during migration. While humans marvel at the spectacle of auroras, these displays signal trouble for migrating birds. Intense solar storms leading to geomagnetic storms and the creation of stunning auroras interfere with certain birds' navigational abilities. The solar cycle is peaking. Evidence from tree rings and ice cores points to much more substantial solar storms in historical records. Approximately 14,000 years ago, Earth experienced a solar flare potentially hundreds of times more powerful than the Carrington flare. NOAA predicts that the ongoing solar cycle will intensify and reach its climax in 2024. Becker likened the prediction of solar storms to forecasting earthquakes, a situation where we lack control. He mentioned that there's approximately a 10% possibility that within the next decade, a significantly substantial event could occur, potentially leading to the disruption of the internet. How can we protect electronics? Becker and his team consciously monitor the sun and simulate flares. Flares, he noted, take approximately 8 minutes to reach Earth, initiating a countdown for the potential magnetic field disruption within 18 to 24 hours. If we receive a warning, every minute becomes crucial because we can activate safety protocols for satellites and take transformers offline from the grid to prevent damage, Becker explained. There are measures that can be taken to mitigate the problem. Looking ahead, there's also the consideration of long-term solutions, such as fortifying the internet. However, this poses an economic challenge because it's akin to an insurance policy. It may never be needed, and the cost of significantly fortifying the system could run into trillions. He highlighted that at present, most major corporations lack the economic incentive to fortify their systems. If you like this video, click the next one shown on the screen. I'm sure you'll like it. Thanks for watching.